In this series of videos, we're going to be looking at elements, compounds and mixtures as part of our introduction to chemistry. The kind of topics that we'll be covering include the particle theory, states of matter, atoms, elements and compounds. In this video, we're going to review the states of matter, specifically the properties of solids, liquids and gases, the particle theory and changes of state. For all of human history, philosophical questions such as what is the world made of have often stoked the intellectual curiosity of people, which in turn has led to scientific explorations of the natural world. Let's begin by reviewing the particle theory. Scientists have come to realize that the matter of the world is made from a few fundamental building blocks of nature. As you should remember from last year, the particle theory says, all matter consists of many very small particles. These particles are constantly moving, they have kinetic energy, or are in a continual state of motion. The higher the temperature, the faster these particles are moving. The differences between solids, liquids and gases can be explained by the particle theory. In a solid, particles of matter are packed closely together and are not free to move about within the substance. Motion for the particles in a solid is confined to very small vibrations of the atoms around their fixed positions. Therefore, solids have a fixed shape that is difficult to change. Solids also have a definite volume, that is, they keep their size no matter how you try to change them. In this picture here that you see on the left-hand side, this is the common representation of the particles of matter in what's called a crystalline lattice. As you can see, they are layered and regularly placed so that each particle is connected to the one next to it. This is what gives solids their particular shape. In a liquid, the particles are attracted to each other. However, liquid particles have more space between them, so they are not fixed in one position. The attraction between the particles in a liquid keeps the volume of a liquid constant. Liquids will flow and fill the lowest portion of a container, taking on the shape of the container but not changing in volume. The limited amount of space between particles means that liquids have only very limited compressibility. What this means is you can't squash liquids. It is this property of liquids that makes them useful in industry, such as in hydraulic systems. Gas particles have a great deal of space between them, and if unconfined, the particles of a gas will spread out indefinitely. If confined, the gas will expand to fill its container. When a gas is put under pressure by reducing the volume of the container, the space between particles is reduced, and the pressure exerted by their collisions increases. If the volume of the container is held constant, but the temperature of the gas increases, then the pressure will also increase. Gas has no definite volume and no definite shape. It takes the shape of the vessel that it's being contained in. This diagram shows the different processes involved when changing state from a solid to a liquid to a gas and back again. What I'd like you to do is take a close look at this diagram and in your glossary find definitions for each of the words attached to one of the directional arrows. For example, take freezing and define it, condensation and define it, deposition and define it. If possible, include an example of these processes. Thanks for watching this video. In class we'll be doing some practical experiments to address the ideas raised and discussed here.